Yeah, good evening. Today I want to explain about this multiplexer design for different modeling styles. First is data flow modeling. So the 4x1 so module Verilog codes will start with module and end module, and this is the identifier mux 4:1 data flow modeling. And so for 4x1 mux we have four inputs and one output and one selection line. So whatever the inputs are there, so I am considering as data input and I am using a vector, and input wire 1:0 selection line and output is y. So here I am using data flow modeling. Assign selection line equal to 2 tick binary 0 0 and d0 is connected, and selection line is 2 tick binary 0 1 and d1 is connected to the output, and selection line is 2 tick binary 1 0 d2 is connected, and selection line is 2 tick binary 1 1 and d3 is connected, or by default we are giving 1 tick x to avoid the latching of this mux. Okay, this is the design, and here we can write the test bench. So we can write the test bench for mux. So this is the code for this one, and next test bench for mux data flow modeling. So this is the test bench. This is the test bench. So if you see module TB mux 8x1 data flow. So whatever the input variables, this is 4x1. This is 4x1. This is 4x1 mux. So here module TB mux 4x1 data flow modeling. So whatever the input variables I need to consider as range variables for the test bench, and output I need to consider as wire, and this is nothing but RTL integration. So we are instantiating the whatever the design through connection by name. Okay, this is RTL integration, and whatever the variables present outside, those are nothing but design inputs, design variables, and whatever the variables inside, those are nothing but test bench inputs. And I need to initialize an integer. Okay, initial begin and display whatever the selection lines, and display this. And I'm using like how many inputs are there. So along with the inputs, 4 inputs and 2 selection lines, total 6 inputs are there. So I am using 2 power 6, 64 possible combinations I am checking. So for this I am using for loop for I equal to 0, I is less than 64, I equal to I plus 1, begin, select comma data input equal to I. So I am waiting for 10 time minutes, and display these values. Okay, display these values and end, and dollar finish and end and end module. Okay, so this one I want to execute. So whatever the module you are executing, right click this and set as stop module. So I need to set as stop module. So I made this TB mux 4x1 data flow modeling as top module. Next, run behavioral simulation. We can see the elaborate design also. So if you see in TCL console, so we are getting the different combinations for this. We made for 256 combinations that will get in the TCL console. So these many combinations will get. Okay, selection D Y, and these many combinations we can check. Okay, and we can see in the waveform also. So we can see in the waveform. So if we can expand and fit to page, and like this I is anyway default value is integer, 32-bit. So here 3 inputs are there. I'm getting different combinations. Depending on the selection line, the output is connected to the input. Okay, so here if you see like so if selection line is 0 0, so y naught is connected to so this d0 is connected to the output. Okay, and here if you see so depending on the selection line, so this is connected to the output. Okay, so I can see the elaborate design also. So I'm closing the simulation. So if you elaborate the design, so elaborating the design, yeah, like that we can see the elaborate design also. And if you see for 4 cross 1 mux using behavioral modeling, so this is if else statement. So if you see this by using if else statement, uh, so we can write the program for if else statement. So module mux 2 cross 1, so whatever the inputs are there, uh, sorry, this is 2 cross 1 mux. I need to see the program for 4 cross 1 mux if else statement. So here input wire 3 is to 0 D and input wire 1 is to 0 selection line. As this is behavioral modeling, so I need to give the reg value as output for reg value. And always at the rate star means what? Always if there is a case sensitivity, always there is a, this is a implication operator. So that means if there any change in the input, all inputs are there, then the output will change. So here we can give the inputs as D input and selection line also. So my means 100 inputs are there. So with the 100 inputs I can't indicate here. That's why I am using implication operator. So if selection line equal to 2 tick binary y, so output D0 is connected to y. Else if selection line equal to 2 tick binary 0 1, output is connected to D1 is connected to output. Else if selection line is equal to 2 tick 1 0, so this D2 is connected to y. Else if so by default D3 is connected to y. So this is the code, design code. And maximum test bench is same only. So test bench will be same only whatever I explained. So here 4 cross 1 if else statement. If else statement, I need to see this test bench. And next if you see for case statement, if else statement, if you see, elaborate the design, so we are getting like it's like a uh, 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 priority mux. It is like a priority mux we will get. Okay, if you see the elaborate design, so that I will show you. But in data flow modeling and case statement, we are getting normal 4 cross 1 mux. 4 cross 1 mux that we will see. So like oh sorry, so whatever the you are doing elaborated design, that you need to make as top module. So in the design here, so I am checking for this one, no? So right click this, and I need to make this as top module. So right click this, set as top. So whatever the design is there, that I need to make as a top module. So next elaborate the design. Mux using 4 class 1 mux using if else statement. Yeah. So if you see here by using if else means by using 2 cross 1 mux, so 2 cross 1 mux and let last one more 2 cross 1 mux, we can design. That means 4 cross 1 mux, how we can design in the 2 cross 1 mux. like in the first level you have two cross one mux, and the output will be given to one more, in the second level you are giving one more two cross one mux. So that's why it's like a priority level. Depending on the priority we get the design. Okay, so we'll get the design. So this is the 4 cross 1 mux by using if else statement. And 4 cross 1 mux using case statement. So basically this one is using like we are using case statement. So whatever the module and identifier mux 4 cross 1 case. So inputs are 4 bit, so D0 to D3, and input is selection line is also input. These are two selection lines, S0 and S1. As this is a behavioral modeling, you need to consider that output as reg variable, and always at the rate star. So that is implication operator. This will be applied to all the inputs. Okay, case select. So if selection, depending on the selection line, case select, I'm using case statement. So if it is case is 0 0, D0 is connected to Y, and if it is 0 1, D1 is connected to Y, and if it is 1 0, D2 is connected to Y, and if it is 1 1, D3 is connected to Y. So default, so if you are not using this default means it will take as a latch. That means it will be connected as a previous inputs. Okay, so that's why in order to avoid that latching of this mux, so default you need to connect as a one tick binary X. Okay, one tick binary X means this is unknown value, end case and end module. Okay, so this is the design. And test bench is same. Test bench for 4 cross 1 mux using same thing. Test bench is same. So here I want to see the elaborate design. So elaborate design, set as top. So I need to make set as top. So whatever the design I want to see, so I need to make a set as top. And so I made mux 4 cross 1 as set as top. So open elaborated design. So I got the same mux. Basically we will prefer case statement only. So that means it is giving a proper design. So that is I0, I1, I2, so which is having 4 inputs and 1 output and 2 selection lines. Data flow modeling also will get the same design only. Data flow modeling I will show. So here whatever the data flow modeling if I am writing, I need to make a stop module in the design. So when we are doing simulation, the simulation part you need to right click and you need to make a stop module. Okay, so open elaborated design. Open elaborated design. Oh, sorry. So for it is data flow modeling also, it is coming uh, like same thing as a priority level. Okay, data flow modeling also. So basically we'll prefer case statement. And suppose if it is smaller design means we can go for gate level modeling and data flow modeling. And if it is we are designing for RTL design, we need to go for behavioral modeling. Behavioral modeling means I'm no need to bother about the circuit functionality. So I means if I know the behavior of the circuit, just if I know the behavior of the circuit, I can write the program. Okay, this is about the mux for different design styles. Okay, thank you.